Hi guys, welcome back to the channel. So in today's video I'm going to be teaching you about cosine rule. So the purpose for this rule is to help us be able to calculate the length of the given triangle. Instead, maybe you are given some value b and c, you will be able to calculate a. If you are given x, you can calculate the angles and all that. So the formula for the cosine rule is given by, if you want to calculate a, it's given by a squared is equals to b squared plus c squared minus 2bc. It's cosine, like we said, it's a cosine rule, then it's cos x, right? If you want to calculate a, the reason we say x is because it's opposite. That means for b it will be y, for c it will be z. So we're going to have b squared is equals to, we're going to replace b by a, it's going to be a squared plus c squared minus 2, it will be ac. AC cosine, what is b? B opposite it's y. Then for c, c squared is given by, we replace c by b, a squared plus b squared minus 2ab, ab cos, what is c? The opposite of c is z. So guys, that is the cosine, the laws of the cosine rule. If you want to calculate c is that means if you want to calculate z, you're going to divide. That means if you want to calculate z, for example, you're going to have cos z is equals to, that means you transpose this, it will be c squared minus a squared plus b squared all over divide by, because we divide by 2ab. If you want to calculate z, that means you'll just say shift cos, then you enter everything here. That means same thing you're gonna do with b. That means for y, if you want to calculate y, it will be cos y is given by, it will be b squared minus a squared plus c squared all over 2ac. It will be 2ac, as you can see is this one. Same thing with cosine x. Then you're gonna say cos x is equals to, is given by a squared minus b squared plus c squared all over 2bc. So basically these are the basics of how to calculate, but the most important thing that they're going to ask you in the exam, most likely to ask you, they're going to ask you to prove the cosine rule. So we're going to prove the cosine rule because they might ask you to prove it, right? So to prove it, we can say prove. Let's just say prove. I'm going to write how they're going to ask you. The law of cosine states that, or for any given triangles, let's say for ABC triangle ABC, we are given triangle ABC with side. Obviously, the side of triangle ABC is going to be A, B, and C. Then it means we're going to have, we're just going to prove one of this. We're going to prove the one with C. C squared is equals to A squared plus B squared minus 2ab, which this is what I'm writing. This one, the last one, cos, then let's just say cos c, because we are given triangle ABC. I'm going to show you the new triangle. So to prove this, obviously, like I said, guys, you're going to decide which one you're going to prove. So in this case, we're going to prove the c. C squared is equals to a squared plus b squared minus 2ab cos c. Most of the time, they will give you this one to prove, right? So you'll be given the triangle ABC. So to be able to prove this, you have to draw this line, the perpendicular line to AC, which is going to be from the vertex B. So it's going to be BD, which is perpendicular to AC. Make sure that you include this line. I already included it on my triangle. You will see where we include it so that we can be able to accommodate this, be able to find CD, be able to find AD separately, right? So make sure that you do that when you prove this theorem or this law, or you can say the rule. So let's start with the proof now. In the triangle BCD, in triangle BCD, you already see why we have the line. So it helps us to have another triangle because it will be hard to prove with one triangle. So we already know that if you want cos C is given by what? The cos, obviously, we know that is the this one, the adjacent, which you can say is the base over the hypothesis. So this here, it's given by, we can just say CD because we don't have anything, divide by the hypothesis, which is A in this case. So you can even solve this and say CD is equals to A cos C, right? So that is in that triangle. That's what we have so far. So if CD is A cos C, CD and DA, if you want to find BA, they are already like terms. So we're going to simplify this to find what? DA, which is already B. Then you're going to solve this. So let's continue with that. So you have to notice that this B here, it's for everything here. It's for AC. The length of AC is B, right? So we already have CD. That means if we want DA, DA is given by what? DA, because we already know it will be B minus CD, which we already know that CD is this. We can substitute this and say B minus, instead of writing CD, we can write A cos C, right? That is our DA. We already have DA, we have CD in terms of this cosine, right? So we're gonna go back to this triangle. The triangle, let's go back again in triangle BCD. So what do we have in triangle DCD? We have the sine of C. What is the sine of C? Knowing that we know SOHCAHTOA already, it's the opposite over this, and the opposite is what? BD over A, right? So if you want BD, you can just simplify it further and say BD is equals to A sine C, right? That means we already have BD in terms of that, and we have this in terms of that. So if we want to calculate C using, because this is 90 degrees, you can just use hypotenuse. We know that if we say C squared is given by, C squared will be given by BD squared plus DA squared, which will be BD squared plus DA squared, right? So that is if you want to calculate C, because this is 90 degrees. I don't know if you already know this, but yeah, I believe that everyone knows this because this is grade 11. You did this in grade 10, which is Pythagoras theorem, right? This is Pythagoras theorem, but you can write it sometimes, like they might give it marks. So you're just going to write Pythagoras theorem. You did this in grade 10, right? So you know that when it's 90 degrees, that is Pythagoras theorem. Then to simplify this further, that means we have what? What is BD? We go back. BD is A sine C plus what is it's squared in this case? Squared. Then what is DA? Our DA is given by B minus A cos C squared, right? So we have to simplify this. Then obviously it's going to give us the right thing. We're going to have A squared sine C squared, just like that, plus this, it will be B minus A cos C into B minus A cos C, which equates to A squared sine squared C plus, to simplify this, obviously you're going to have B squared. This will be minus minus, it will be minus 2 minus 2AB 2AB cos C plus A squared cos squared C, right? So we have the like terms of A, which we're going to say A squared into sine squared C. You take this side, is going to be plus cos squared C plus B squared, which is this one, minus 2AB cos C, right? So we already know from the rules of trigonometric identities that sine squared C plus cos squared C is equals to 1, right? So we're just gonna leave it. It's going to be A squared plus b squared, which is this one, minus 2ab cos c. So that is the proof. You are done from here. You can see it from here. You'll be done. So the most important thing to note here, guys, is that you will be given a triangle ABC. The first thing that you do, you draw a perpendicular line to introduce another value, which is going to be D. You're going to have A, B, C, D. Then after that, you want to find AD in terms of cos. You want to find AD so that you can use it in your Pythagoras theorem. Because if you have AD and BD, the goal is to find BD and AD to find C. You start by solving this triangle, then after conclude with finding C. So that is the rules of this thing. The most important thing is to remember, draw this line. Then after you draw this line, just go with the flow. In triangle this, you find what? CD. Then you go again in that triangle, you find BD. Then already with CD, you just substitute it, find AD. Then you have this two, theorem of Pythagoras. Then you're going to find this solution here, the final solution. I hope you understand it. If you don't understand it, you can ask in the comment section. If you do, then we're going to solve the questions of this now. Thank you.